Good morning, students. Today we are going to see the unit 3. It is called Chemical and Electrochemical Energy Based Processes. First, we will see the chemical energy based process. In chemical energy methods, the metal is removed from the workpiece through controlled etching of the workpiece material in contact with the chemical solution. Example, chemical machining, CHM. In electrochemical energy methods, material is removed by ion displacement of a workpiece material in contact with chemical solution. Example, electrochemical machining, ECM, electrochemical grinding, ECG, electrochemical awning, ECH, electrochemical deburring, ECD. First, we'll see about the chemical machining process, also called as chemical milling process. Construction. In this process, material is removed from the workpiece through a controlled etching or chemical attack of the workpiece material. Material can be removed from selected areas of workpiece or from the entire surface of the workpiece according to requirement. If selective machining is desired, the area of the workpiece which are not to be machined are covered with a resistance material called a resist or maskant. The workpiece to be machined is first cleaned in trichloroethylene vapor or in a solution of mild alkaline at 85 to 90 degrees Celsius, followed by washing in a clean water. This removes dust and oil from workpiece. After cleaning, the workpiece is dried and coated with masking material. The workpiece is then immersed in a chemical reagent as shown in figure. So chemical reaction take place and metal is removed from workpiece. The metal is removed by the chemical conversion of the metal into metallic salt. The time of immersion of workpiece depends upon the amount of material removed by chemical action. The chemical etching agent depends upon work material. Caustic soda is used as etching reagent for aluminum. Solution of hydrochloric and nitric acids for steel and iron chloride for stainless steel. In order to obtain a uniform depth of metal removal, temperature control and stirring of chemical reagent is important. After machining, the workpiece should be washed thoroughly to prevent reaction with any chemical etching reagent residue. Now we will see about etchant. What is etchant? The chemical reagent etchant is used to remove the metal from the workpiece. The metal is removed by the chemical conversion of the metal into metallic salt. The chemical etchant reagent depends upon work material. The following table shows the etchant for different materials. Number one, material aluminum, caustic soda. Number two, scale, hydrochloric acid or nitric acid. Number three, stainless steel, iron chloride. Number four, magnesium nitric acid. Number five, titanium nitric acid. Next, we are going to study about the maskant, which is an important part. What is maskant? In chemical machining process, the areas of the workpiece which are not to be machined or covered with a resistant material is called maskant. For example, if their maskant where they are applying in workpiece, that area will not be machined. Others area will be tend to machine. The following tables shows the maskant for different materials. Material aluminum, butyl rubber, neoprene rubber. For using aluminum material machining, we should use a maskant, the material called butyl rubber maskant and neoprene rubber. For example, for using magnesium, we should use polymers as a maskant. For titanium, we should use a maskant material called translucent fluorinated polymers. If we are using a nickel material, then we should use a neoprene. When we are using a ferrous metals, then we should use a polyvinyl chloride or polyethylene. Methods of masking. The usual method of masking are scribed or peeled maskings. What is scribed and peeled masking? Second one is photoresist masking. First we will see about the scribed or peeled masking. In this method, a maskant like paint is applied to the entire surface of the workpiece by dip, spray, brush or stencil after the maskant hardens. It is removed from those surfaces where metal removal is desired. The maskant is removed by scribing with knife and peeling away the desired surfaces. Templates can be used to assist in scribing. This method is used when critical dimension tolerance are not required. Second method of masking is photoresist masking. It is an excellent method of masking, especially for complex works. This method is used for thin sections and components requiring closed dimensional tolerance. The workpiece the workpiece to be machined is thoroughly cleaned and decreased by acid or alkali. The cleaned metal is dried and photoresist material is applied to the workpiece by dipping, spraying, brushing, or roller coating. The coating is then dried and hardened by heating in an oven up to about 125 degrees Celsius. The design of the pot to be machined is prepared at a magnification of up to 100x. The master drawing is photographed and reduced to the size of the finished pot. The master photographic negative is placed over the dried photoresist coated surface of the workpiece and exposed to ultraviolet light, which hardens the exposed area. After exposure, the workpiece is then developed by immersing it into a tank which contains an organic solvent bath. After exposure, the workpiece is then developed by immersing it into a tank which contains an organic solvent bathroom solutions, solvent bath solutions. The unexposed portion are dissolved out during the developing process, while the exposed portion remains on the workpiece. Finally, the treated workpiece is dipped into the etching solution. After 5 to 15 minutes, the unwanted metal is removed from the workpiece and the finished pot is washed thoroughly to eliminate all chemical residue. Metal Next is we are going to see about a metal removal rate. Metal removal rate mainly depends upon the selection of the etchant. Metal removal rate is fast with certain etchant. It increases undercutting, poor surface finish, and more heating take place. So etch rate is limited to 0.02 to 0.04 mm per minute. Etching rate and depth of cut are high for odd material. Titanium alloy, stainless steel, and heat resistant alloy, and low for softer material aluminum with optimum time, temperature, and solution control. Accuracies of order of plus or minus 0.01 mm is obtained. Surface finishes of order of 5 microns is produced. The size of the workpiece mainly depends that can be treated in limited only by the size of the tank in which the workpiece is dipped for etching. Next, in chemical machining process, we can be classified into chemical blanking and chemical machining. Chemical blanking. In chemical blanking, the material is etched directly or entirely on the workpiece. It is used for cutting out parts from thin sheet metals or foil sheets. Contour machining. In contour machining, the material is selectively etched from certain areas on the workpiece. It is used for removing metals from thicker workpiece. Now we will be seeing about the applications of CHM. Chemical machining process is applied in greater number of usages where the depth of metal removal is critical to a few microns and the tolerance are close. The major applications of chemical machining is in the manufacture of burr-free components. Now we will see the advantages of chemical machining process. Burr-free components are produced. Most difficult to machine materials can be processed. High surface finish is obtained. Any metal can be machined. Stress-free components are produced. Since the process is comparatively simple, there is no need of highly skilled labor. Both phases of the workpiece can be machined simultaneously. Hard and brittle material can be machined. Tooling cost is very low. Complex contours can be easily machined. Disadvantages of CHM. Since process is slow, metal removal rate is low. Manufacturing cost is high. Workpiece thickness that can be machined is limited. Larger floor area is needed. It is not possible to produce sharp corners. Thank you.